Hey guys, this is 6.4. 6.4 is called dividing polynomials. So we have looked at simplifying rational expressions. You know how to simplify, you know how to multiply them, you know how to divide them. And we really focused on the ability to factor. Like all through this course, we have been practicing factoring, and it's really going to impact all future math classes. Is your ability to factor and understand factoring. So now we are moving from rational expressions to polynomial expressions, dividing polynomials. At first, we're just going to divide a polynomial, which means it has many terms, by a monomial that only has one term. Those are kind of fun. It's just factoring. And the other one is going to be more like when we're dividing a polynomial by a polynomial, it would be more like long division. All right. Polynomials, poly just means many, right? And then a nomial is a term or a number. Dividing a polynomial by a monomial. We have added polynomials, we have subtracted polynomials, we have multiplied polynomials. Today we will divide polynomials, right? Divide each term. A term is anything that is separated by a plus or a minus sign, okay? So a term could be one number, a constant, it could be a 5, it could be an x, or it could be like a 5x. Those would all be terms. And we would separate them with a plus or a minus. So this would have two terms. This would have one term. There's one term in the bottom. Divide each term in the polynomial. That's on top. There are two. By the monomial. Mono means one. All right. So a monomial has one term. Many. And c cannot be 0 because if we divide by 0, it would be undefined, and then it's not a real solution, right? If I have a polynomial divided by a monomial, I split it up. So let's see, a is, so we have a plus b divided by c. A is being divided by c. And b is being divided by c. They are split into individual functions, and then it might be easier to simplify them after we have split them into individual fractions. Another way to say it is a plus b over c becomes a over c plus b over c. All right, let's practice. Here we have three separate terms in our polynomial. We have negative 12a to the third, we have positive 36a, and we have negative 15. These three terms are being divided by 3a. So let's divide it. We are dividing by 3a. Okay. Negative 12a to the third will be placed over 3a. So I'm just separating it out. Oops, sorry. Negative 12a to the third over 3a. This is a plus, so I'm going to put a plus between them. 36a over 3a. And then I'm going to put a minus 15 over 3a. You could also put a plus and then make the 15 a negative. Whatever. A to the third. Well, let's first think about, can I simplify the individual fractions? All right. How many times can 3 go into a negative 12, right? 3 goes into negative 12, a negative 4 times, right? 3 goes into 36, a positive 12 times. And 3 goes into a negative 15, negative 5. Good. So now I said, so 12 divided by 3 just becomes negative 4. 36 divided by 3 becomes 12, or 15 divided by 3 becomes 5, right? Now we have the a. A to the third power means there are 3 a's on the top of this fraction, and there's 1 a on the bottom, right? So that's like saying, ooh, I can just write it out. I have 3 a's up here, and I have 1 a down here, right? Here I have 1 a and 1 a. Here I have no a's on top and 1 a on bottom. So put that plus sign and that minus sign in. Ooh, hold on. Sorry, my computer battery decided. All right, so I have negative 4 a to the third over a plus 12a over a minus 5 over a. Okay. I can cancel out some of these a's. So anything divided by itself is 1. So that becomes, instead of 12a over a, it's 12 times 1, which is 12. There are no a's up here, so I can't cancel this a. That a stays. Here I have 3 on top, 1 on the bottom. I can cancel 1, right? So that then becomes, our third iteration is negative 4a. A times a is just a squared. There's nothing on the bottom. Plus 12, all the a's cancel out, minus 5 over a. So I leave that as a fraction because the a is on the bottom. Good. Here we have 10t to the fourth minus 35t cubed plus 5t squared over 5t squared. All right. I encourage you to pause right now. You try to solve it. Once you get to your answer, play it or fast forward it and see if you got the same thing that I did. Okay, so pause it right now. See what you get compared to what I did. All right. So it was 10 to the fourth over 5 squared. So we separated it out. Minus 35 t cubed over 5t squared plus 5t squared over 5t squared. 10 divided by 5 is 2. 2t to the fourth over t squared. 35 divided by 5 is a 7. T to the third over t squared plus 5t squared over 5t squared. That's exactly the same, right? So I should just do those together. So is that, if you have something divided by itself, does that become 1 or does that become 0? What do I need to put here? Well, we can check our calculator. 5 divided by 5 is 1. And sometimes we can ignore the 1, right? Like a divided by a is 1. So 1 times 12 is 12. But so I left out that 1. I didn't need to say 12 times 1. But here, there's nothing to multiply the 1 by, so I have to leave the 1. If I didn't leave it, then it would disappear entirely, and that's not nothing. That's 1. Okay. So now let's look at our variables. Up here, I spaced them out and canceled them 1 by 1. You can also subtract, right? 3, the laws of exponents say you can subtract the exponents when you're dividing and the base is the same. So a to the third minus, so a to the third divided by a to the first is just 3 minus 1, which is 2. 1 minus 1 is 0, they cancel out. So here, instead of writing it all out, I'm just going to subtract it. T to the fourth divided by t squared is just 4 minus 2, which is 2. 2t squared. 3 minus 2 is 1 minus 7t plus 1. Is that what you got? Good. If you have 3 terms in the numerator, you should always have 3 terms in your final answer so you can account for each one. All right, now we are moving on to polynomials. Dividing a polynomial by a polynomial other than a monomial uses the long division technique, similar to the process known as long division when we divide 2 numbers. Right? Sorry. Okay. So this is what we do when the denominator is not a monomial. And if you remember long division from earlier in your life, in your math life, let's review it really quickly with a whole number. Okay. So I'm going to say 526 divided by 3. Okay. So what we want to do is take the first term of what you're multiplying into and the first term of what you're multiplying by. So 5 and 3. And I think, what do I multiply 3 by? Get as close as possible to 5 without going over. Okay. So 3 get close to 5. 3 times 1 is 3. 3 times 2 is 6. So I have to say 1, right? I put that 1 up here. I'm going to take that 1 and I'm going to multiply it by the 3. 1 times 3 is 3. And then the most important step, remember that you're subtracting. Okay? So we multiply it as though it's equal, and then we subtract it. 5 minus 3 is 2. Now that number is too small to divide into 3, so I'm going to bring down the other one. 2. 22. Right? The remainder is 2. It's too small to divide by 3, so I bring the next digit down. What can I multiply 3 by? As close as possible to 22. That would be 7, right? 3 times 7 is 21. I put the 7 above the 2 or next to the 1. Take that 7, multiply the 3 by the 7 to get a 21. Remember to subtract. 22 minus 21 is just a 1, right? I can't divide that, so I'm going to bring down the next digit. Now I have a 16. 3 times what gets me close to a 16? It would be a 5, right? 5 times 3 is 15. And remember, I am subtracting. Finally, I have a 1 left over. 16 minus 15 is 1. That 1, since there are no more digits to bring down, I have to say is my remainder. What we do with our remainder is we put it over that number. 175 and 1/3 is my final answer. The 1 remainder over what we were dividing by. 175 and 1/3 times 3 is 526. Okay. All right. These are the same skills we will use for the next problem. I'm going to skip slide 6 and just go straight to slide 7 because that was our example. All right. For example 3, when dividing, look at the first term. Let's look at it. Make sure to leave a space for anything that is not in the correct order. Okay. So here we have c squared, c to the first, and c to the 0. That's perfect. But if you had something like x plus x to the third minus 5, all divided by x. When I'm getting ready to divide this, I want to put it in the correct order. So I want to put it in descending order. So x on the outside. And then I would say x to the third. And then I would put a 0 x squared in. So that my place values are, so that my division is correct. Then I have enough space. Plus that x minus 5. Okay. So leave spaces if you ever have a gap in the exponent. We do not have a gap in the exponents. We're okay. The way we set this up is you are dividing into, you are dividing into c squared plus 3c minus 2. You're dividing by c plus 1. So I'm dividing c squared plus 3c minus 2 by c plus 1. I make a house. No, I was all you make a house. You put what you're dividing into inside the house. And then you take what you're dividing by and put it out. Good? Okay. So just like with the whole number 3 and 526, right? We look at the first term of what you're dividing by, the first term of what you're dividing into, only the first term. Only the first term. Okay? And you say, what can I multiply this one by to get as close as possible to this one? What can I multiply c by to get as close as possible to c squared? That's c, right? Now I take that c and I multiply it by everything over here. Okay. C times c is c squared. That goes right here. C times 1 is c. So you see how it's important. Do you see how it's important to have the squared, the c, and the constant lined up correctly? You don't want to skip anything. Now, remember, we subtract. So we're subtracting, so we're changing this sign, and remember to change this sign, okay? C squared minus c squared cancels. A positive 2c, and remember this is being subtracted, minus c is just 2c. Because this has 2 terms, I want this to have 2 terms, so I'm going to bring down the negative 2. Now, 2c minus 2, c plus 1. Just looking at my first term, how can I get close to 2c from c? C times positive 2. I'm going to take that positive 2 and multiply it by everything over here. 2 times c is 2c. 2 times 1 is 2. Okay. Remember, I'm going to subtract it. 2c minus 2c cancels out. Negative 2, remember this becomes a minus 2, is a negative 4. And that is my remainder. There's nothing left over here. So the way I write this is, my answer is c plus 2. And remember, if we have a remainder, we put it over what we're dividing by, minus 4 over c plus 1. That is as simple as I can make this answer. Okay? Okay. This was a vertical fraction. This is a vertical. Now we're going to do a horizontal fraction. This one's going up and down. This one's going all the way across. But this is still into, we are dividing y minus 2 into y squared minus 5y plus 6. And we are dividing y squared minus 5y plus 6 by y minus 2. Okay? Same setup in the house. Inside the house is what you're dividing into, y squared minus 5y plus 6. Outside the house, I'm going to have y minus 2. Okay? Same rule. Look at the first term of what I'm dividing into and what I'm dividing by. To get to y squared from y, I'm going to multiply by y. Y times y is y squared. Y times a negative 2 is negative 2y. Subtract. Y squared minus y squared cancels out. Negative 5y plus 2y being subtracted is negative 3y. Right? I have two terms here, so I need to bring down a second term. Now I have negative 3y. Only look at your first term and y. To get a negative 3y from y, I need to multiply by a negative 3. Now I'm going to multiply that negative 3 by everything. Y times negative 3 is negative 3y. Negative 3 times a negative 2 is a positive 6. Remember, subtract. Negative minus a negative cancel each other out. Positive 6 minus 6 also cancel each other out. So your final answer is y minus 3. No remaining. Example 5. Again, check for holes. X to the third, x squared, x, and x to the 0, or a constant. X minus 2. We're okay. All right. We are dividing this by this, as it says, or we're dividing this into that. All right. So we have x minus 2 outside the house, and inside the house we have 3x to the third minus 2x squared plus 5x plus 4. Okay, so just looking at your first term and your first term, if I want 3x to the third out of x, I need to multiply x by 3x squared, right? 3x squared times x is 3x to the third. 3x squared times a negative 2 is negative 6x squared. These cancel. Oh, sorry. We're subtracting, but they cancel. Negative 2x squared plus 6x is 4x squared, right? Bring down the next term. Plus 5x. Look at my first term here. My first term here. 4x squared into x means I need to multiply it by a positive 4x, right? Positive 4x times x is 4x squared. Positive 4x times a negative 2 is negative 8x. Oops. We need to subtract it. 4x squared minus 4x squared cancel each other out. 5x plus 8x becomes 13x. And I'm going to bring that 4 down. Positive 4. Here I have a 13x and an x. So I need to multiply the x by a positive 13. Take that 13, multiply everything by the 13. I get 13x minus 13 times 2 is 26. Okay. Subtract 13x minus 13x cancels. 4 plus 26, so you can just take 30. And that is my remainder. There's nothing else to bring down. So my answer will be 3x squared plus 4x plus 13 plus positive 30, 30 over x minus. And that is my answer. Okay. That was the long division way of doing it. If that makes sense to you, great. If you want a short, if that makes sense to you, and you're like, oh, I don't want a shortcut. I want a way to do that even faster. I'm ready for a challenge. You can also try synthetic division. Okay, it's just a way to do it faster. So it's not anything you must learn. It's just faster if in fact you do it. Okay. So to find the quotient and remainder, that's these guys. When a polynomial of degree 1 or higher is divided by x minus c, a shortened version of long division called synthetic division may be used. It can be used when the divisor is a binomial of degree 1. So this is, when they say divisor, they mean this guy. Here's our divisor. So this number, or sorry, this polynomial cannot have any higher exponent. It has to just be the letter x, the variable x, c, y, whatever variable we're using, right? And then this has to be a whole number, or sorry, this has to be just a number without any limits, okay? So, for example, if we said our divisor was 2x plus 3, you could not use it. If our divisor was x squared minus 5, you could not use it, okay? It only works with your x plus a number or your x minus a number, okay? These are okay, these will not work for synthetic division. Your divisor should be very plain, all right? This can be whatever, but this must be plain. Okay. Instead of subtracting, there was a lot of subtracting in these examples, right? At every single step, we just do the subtraction at the beginning for synthetic division. We take the opposite of whatever that number is, okay? We leave all the variables out. There will be no c's in synthetic division. The first terms always cancel if you do that. This term canceled, this term canceled, this term canceled. That was our first term. So it's kind of like we didn't even need that. Yeah. So what we're saying is we don't need the x and we need the 2 to be positive, and then we can just do it really fast, right? Because every subtraction made the 2 into its opposite. So I'll just say plus 2 and there are no x. It sounds confusing, but after we do a few examples, you'll understand a little bit better what I'm saying. Okay, so we're going to take the opposite of the constant. The constant is plus 1. We're going to put it in the divided box. And instead of rewriting c over and over, we're going to leave it out. So here's a divisor box. We're going to do the opposite of the constant, -1, because the constant is positive. Okay. Now I'm going to write out the coefficients, none of the c. So this is 1 c squared, so I'm just going to put 1 right here. This is a positive 3c, so I'm going to put 3 right here, and this is a negative looking at my computer screen. Let me try to draw a straight line. All right. That is how you begin synthetic division. Instead of this, we have this. And actually, let's compare this truly to the example we had. The example we had was right here. Same problem, right? So instead of writing out c plus 1, division bar, c squared plus 2c minus 2, sorry, 3c minus 2, I have that becomes that, that becomes that, that becomes that, and that becomes that. Okay? So, what do we do? What do we do with it? We take the first term, bring it straight. 1, bring it straight down. Okay? Multiply it by what is in the divisor box. 1 times -1 becomes -1. We're going to put that number right here. This is this number times whatever is in the divisor box. Okay? We put it in the next column. Now we subtract. We don't need to change, or sorry, we combine. We don't need to change anything because we already used subtraction over here. 3 minus 1 is 2. Okay? I'm going to take that term, multiply by what's in the divisor box, remember? 2 times -1 is going to be a -2. We're going to combine these. 2 combined with -2 is -4. This is my remainder. So this will be my constant, and this will be my c. Good. So I have 1c, a constant, and the remainder over c plus 1. Okay? So I'm adding back in the constant. C, 1c, 2, or sorry, I'm adding back in the variables. 1c, 2 minus 4 over c plus 1. Or you can add the c's in by subtracting 1 degree and just starting with the next degree. So I'm going to start with c, because this began with c squared. C plus 2 minus 4 over c plus 1. And that is the same as the answer we got here. So they give you the same answer. Example 6 was y squared minus 5y plus 6 divided by y minus 2. Okay, so we are going to do the opposite, the same thing. In the divisor box, we're going to have the opposite of -2, which is +2, right? Outside the divisor box, I'm going to write everything without the variable y. So I have a 1y squared, I have a -5y, and I have a +6. And we take that 1, bring it straight down, just like last time. So that's here. The 1 multiplied by what is in the divisor box. The 1 multiplied by 2 in the divisor box gives me 2, so I'll put that right here. -5 combined with 2 becomes a -3. -3 times the number in the divisor box, -3 times 2 is a -6. 6 combined with a -6 is just 0. This is my remainder. My remainder is 0. My constant is -3. And then my 1 is a y back. So we have y minus 3. The remainder is 0. I don't think it's good. And that is the same answer we got here. Last one. Now example 7. in my divisor box, I have a positive 2. Outside the divisor box, I'm going to have a 3, a negative 2, positive 5, so I don't think that's possible, and a 4. Good? Remember, we take that first term, bring it straight down. Multiply it by whatever's in the divisor box. 3 times 2 is 6. Negative 2 combined with the 6 is a 4. Right? Now I'm going to take that 4, multiply it by the divisor box. 4 times 2 is 8. 8 and 5 together make 13. Take that number, multiply it by the divisor box. I have a 26. 26 combined with 4 is a 30. 30 is my remainder. 13 is my constant. 4 is an x, and 3 is an x squared. Another way to look at it is take one exponent off and start with the next one. So we have 3x squared plus 4x plus 13 plus 30 over x minus 2 because it was my remainder. Okay? And that is the same as the answer I got over here. That is how to use synthetic division to just do long division a bit faster with polynomials. And that, I believe, is our last example. Thank you guys so very much. And I will. And I will see you next time. Bye.